All right, good. So now we're going to talk about the EOSC Federation. We are going to launch it softly. We are going to start with a couple of introductions, right? And for this, it is my pleasure to invite Bob Jones, who is a special envoy to the EOSC Federation from the EOSC Association. Bob, the floor is yours.
Well, good afternoon, everybody, and thanks for coming back after the coffee. So, as announced, this session is dedicated to the launching of the EOSC Federation, and I will give you a brief, and I mean brief, introduction to the Federation and what's been happening. So, the overall vision, we know what it is to establish this system that enables researchers in Europe to store, share, process, analyze, reuse fair research outputs, and that's being put in place. We understood as well that EOSC is wider than the EOSC Federation, but here we're focusing on a concrete vehicle that can help us implement some of those aspects. And we're taking the system of systems approach that Klaus explained to you with the different features that you see below there. And if we see what this actually meant, well, as was mentioned earlier, we have gone through a whole process. If we remember last time that we came together for the symposium in Berlin, there was just been the launch of the EU node, the first node in the Federation, and we'd started this whole process of the questionnaire to which we got more than 120 responses and going through a dialogue process. Well, eventually that brought us down to 13 first wave candidate nodes, and here you can see them on the slides. So we started with a mixture of national, thematic, and e-infrastructure nodes to represent the different stakeholders who are all investing inside EOSC. And over the year, I think actually Volker said it's been fast and furious. He's absolutely right. It's been 7 months that these nodes have come together and doing a lot of work. And I'm pleased to say that we've gone from these candidates of what could be the potential first wave nodes to now this set of nodes which are interacting and working together. And this mixture of thematic, national and e-infrastructure nodes, and of course the EU node. And so you can see those of them today. You'll see them in the booths, in the exhibition hall. Go and talk to them, ask them questions. They've got videos, they've got demos of how these things work, and they can tell you all the details. If you want to become a node in the future, now is the opportunity to talk to these people and understand really what did it involve and what work did it mean. But what it also shows is that with this, they're already federating more than 30 service and research project catalogues. That doesn't mean just 30 services, it means more than that, but the catalogues, and Peter will give you more details about those. And of course, it's growing. As more information is harvested, as more services are onboarded into those nodes, the federation is growing gradually, and we're learning more about it as we put this together. Well, how do we actually organize all of this? Well, we put together something called the build-up group as a sort of coordination across all the nodes. So each of those organizations nominated a coordinator as a role. They come together, they've been meeting monthly, and the first time we came together was here in Brussels in March this year, so only seven months ago. And we quickly realized that we have to put together specialized subgroups for different subjects. The subjects you see here, the 9, they were suggested by the nodes themselves, and we selected through them, and then they had to be endorsed by the node coordinators so that we could actually form those subgroups. So we have the capabilities like the federated AAI, the service catalogs, and so on. In the resources, integrating scientific data repositories, file sync and share, which you can also see as a demo later today and on the nodes as well. And the science workflows and scientific health data, that's pretty much launched to the idea of the use cases, and we'll see more about those. And then the overall governance or coordination part, where we have the cybersecurity, which has recently been formed, bringing together cybersecurity experts from each of the nodes. The preparation of the MOU, which I'll speak a little bit more about afterwards, and then the handbook review. The handbook's been mentioned. There's been a work to go on and review that as going ahead. So these got formed. We had a sort of mid-year stock taking in Krakow in June, and there's where we also looked into detail about what is the next steps we have to do in the deployment of the use cases as well. And then we did an assessment in Helsinki in October this year, and you'll see some of the results of that, where we checked what is the status and have we managed to achieve what were the objectives for 2025. So some of the outputs from this build-up group, first thing I would say is they've enabled us to come up with consensus across the nodes. We've talked before about what is the involvement of the nodes. Well, they've been directly involved in agreeing on these technical specifications for the federated capabilities. The federated AI, it's been launched earlier, several years before, going through preparatory projects like Arctree and so on, and that was agreed with the nodes, and it's published on Zenodo, the specifications, so others can see that as well. Same thing for the federated catalogs. It took a bit longer setting up the service and the resource product catalogs, but that's been published as well, and those have come out of the two subgroups. There are other federating capabilities which we have not yet had much experience with. We've only worked with these two mandatory ones so far. There are 6 more at the bottom there. We have to go through the process of introducing those as we get more experience. But at the moment, it's limited. Yes, maybe each of the nodes have its own help desk, but we haven't linked them together yet. So those sort of things need to go on. Similarly for the monitoring, understanding what is the usage across each one of those and how can we increase those as we go forward. So there's still a lot of work to be done there. The other part that I mentioned was the MOU, so this memorandum of understanding. Up until now, it's been basically a verbal agreement between all the partners working in the federation of how we will build it. There's been no signatures, no structure there. As a next step, there's been a subgroup that's prepared a memorandum of understanding, which you'll hear more about later today and tomorrow, which outlines what's the sort of the roles and principles for this collaboration, an interim collaboration. It's still not legally binding, but it puts us on a good basis for what we need to do for when we want to get to a production system in the end. So that's been put in place, and again, has reached consensus across the participating nodes. The other part I mentioned was the thinking of what Klaus talked about, the end users. It's been very important for us to try and track some use cases across the federation. Each node itself has come up with a list of use cases. And from the overall build-up point of view, we have tracked only 6 of those because 6 of them were considered to be multi-node scientific use cases. And I won't go into details about them, but again, you see them from different disciplines, and you can see some more of those later this afternoon, and also in the other sessions that are going to take place tomorrow. But these are just a subset. As I said, many of the nodes have a lot more use cases, and these are pushing the boundaries to make sure that the nodes are actually deployed and can be useful to the research in their daily work. The other part that's been a lot of work as well is we published the Federation Handbook in March of this year, so just as the build-up group was starting. And what we're looking at now with another subgroup is how we will revise that handbook to take into account the lessons learned from the deployment by the first wave nodes. So all those 13 nodes plus the EU node, and also input from the task forces who are contributing towards this, as well as the opportunity areas, expert groups and projects. So that's been being revised, lots of feedback has been gathered, and we expect to have a new version of that handbook published by December of this year. Trying to keep it the same length. We don't want it to grow in size. Trying to keep it to about 50 pages, but bring it up to date, making it more concrete and correct so it reflects what needs to be done if you want to participate in the federation as a new node or as a service or resource contributor as well. So when we met in Helsinki, we did an assessment of what we were trying to do. We said at the start of 2025, these are the things we want to do by Q4. So we wanted to have several enrolled nodes. Well, the first wave nodes are there. You'll see them. We have 10 of them that are actually functioning. 3 of them have onboarded resources to the EU node, and Peter will tell you more about those. We've established a first operational structure for it, so through the build-up group, with the roles and responsibilities, and then looking to the future with the MOU. We have an application process to become an EU node. The first time round, it was very much learning by doing. Now we have a documented process, documented criteria that have been agreed with the tripartite. So for those of you coming into the federation now, the situation and the process is a lot clearer, and we can manage it more easily as well. And we have a first edition of the federation-wide policies, the rules of participation, including the eligibility criteria. We have examples of the access and acceptable usage policies coming from the EU node, which we want to try and generalize and make available to the other nodes as well. And we've started the work on cyber security, privacy, and data protection, but it hasn't got as far yet as we want. We recognize a lot more work needs to be done there, and that's one of the priorities for the future. We have a first edition of the EOSC interoperability framework based on a lot of the work that was done before in the previous projects before we started, but with additions coming from the work with the federating capabilities as well. And we've demonstrated the cross-node utilization of some of these federating capabilities, notably federated AAI and the federated catalogs, and you'll see those in use with the use cases. So looking beyond those things, what I have to highlight is this has all been voluntary work. There's been no specific funding call to set up these nodes. So I'd like to say a great thank you to all of these people that have been involved in putting this up in the first wave nodes and the EU node. Thank you very much indeed for your contributions with the support.
Thank you, Bob. All right, we'll keep going. And so next is Peter Sadeghi from DG Connect, right? Policy officer. Everybody knows you, maybe, but I still need to do it. So you're policy officer in the unit for HPC and applications, DG Connect, European Commission. Peter, over to you.
Good afternoon. Thank you so much for having me, especially the nice introduction. You already know me. That's great. So what works? Let's see. We have something to celebrate right away. The EOSC node, we are 1 year old now. We went into production at the Symposium last year, right? So you see all the history back there. Of course, we learned a lot in this 1 year operations. We have about 4,000 registered users. 2.5 million virtual credits are sitting in user wallets today to be used. And of course, as we promised, we have some happy users. They are mostly happy about some of the application services, file sync and share, notebooks. They are particularly happy with the credit ecosystem as a concept. For most of them, it works very well. Some of them are even willing to pay for additional support or more credits, if that's possible. On the other side, of course, we have some critical users, I would say. We do understand that sometimes the credits are not enough, or you're falling into a wrong policy group. We also acknowledge the quite steep learning curve for certain services, like the infrastructure services, even with the documentations we have available. And of course, we also have some genuine requests from demanding users. They want to run services more production-like. For that reason, they need probably more credits. They would appreciate if EC-funded project would get some guaranteed access to the node. So what we are doing, actually, we're all listening and analyzing these feedback, and we're trying to address them. The way how we address them is to changing the user access policy, which is a major policy, but also we're making technical adjustments in the services. We've already done one user access policy change back in May this year. We gave more credits, we adjusted some of the services, but this time we launched these 4 new updates to the policy, which create a new behavior for all of our end users. This was launched Friday last week, so fresh from the oven. If you log in today to the EOSC, you will already find these things. So one of the requests to make the file storage more permanent. For that reason, we changed the behavior of the file sync and share service. You opt in once, you can keep that storage forever as long as you are a user of the node. Of course, that is an underlying file storage for notebooks as well. So we basically killed 2 birds with 1 stone, making that more perpetual. We also adjusted the t-shirt sizes. We gave more resources in the mid-size virtual environment. And together with the yet again increased virtual credit numbers. So if you're a researcher, you will get 2,000 credits renewing every 90 days. You can create 2 of your user groups with 6,000 credits each. So actually, if you have one of those group accounts, you can now run a 4 CPU environment. You can reserve up to 4 CPU environment that will run for you 24/7, right? Your credits will never expire. You can always renew them at the next 90-day period. So with that, you can also run production-like services on the EOSQ node, dedicating one of your group accounts for that reason. And we also extended some of the scope of our user base. The most important one is that we propose in the AUP a new method how we will give a one-time top-up for EC-funded projects. Of course, you have to request that via the help desk. We'll follow up on you, but basically, if you are a funded project, you can get 40,000 virtual credits, and we actually tested this with some of the onboarders, how it works in reality. Last but not least about the EOSQ node is that we have a brand new user design. It's more a user interface design. It's more user-friendly. On the top bar, we separated out all your user account type of actions, and on the left-hand side, you see only the services. At the bottom, you can review your credits. So it's much cleaner view, if you like. Okay, so that's all about the EOSQ node in production, right? So if you log in today, you will see all those changes. What you will not see, because these are only in the testing environment, is all the things that are coming next. We offered 2 basic modalities for our node candidates and the community who we worked with during the build-up phase. One was to onboard services to the EOSQ node, that's the onboarding modality, and the other one was the enrollment, of course, enroll your node, establish your node, and enroll it into the EOSC Federation. As long as the onboarding concerns, we work with CERN, NFDI, and the life sciences community to onboard those 5 services. You will see them in the next coming demonstrations. I only have one video demonstration here. So this is about the ESCAPE VRE from CERN. On the top, you see our traditional Jupyter notebooks, and the bottom, those are the special flavors for the ESCAPE VRE. So those notebooks, if you launch those notebooks, you will be inside the EOSC VRE. There are 2 other services from one other service from CERN, which is Rihanna. You will see the demo soon. And we have Galaxy from NFDI and also from the life sciences community already integrated in our test environment. What I'm going to show you with this video, it will be quite quick, so you should try and capture it. If I lose you halfway, you can always meet at the booth out there, and we can show you a slow-motion version of this. Basically, what will happen here is single sign-on. So the user will log into the EOSQ node, find 2 services onboarded, which are Zenodo and Indigo, and access them. So hopefully the video will play. Indeed, so you see that Yorgos from Athena is logging in via his home credentials. He's logged in to the EOSQ node, finding the deposit type of service on the EOSQ node. There is a warning that is a third-party service, right, provided by CERN. And there you go, and as you can see on the right top corner, he's already logged in, right? Single sign-on worked. Back to Indigo and back to the EOSQ node. If you go under My Events, you will find Indigo. By the way, the EOSC Symposium agenda is running in Indigo, so you must be familiar with it. Again, if you go to Indigo, you will see the user already logged in, right? So this is very basic single sign-on workflow, which we offer for all those services who chose the onboarding workflow. So enrollment, what do we do how do we support as the EOSQ node for all those node candidates who are enrolling? First of all, we do the node registry. So you have to register your node with us. And with that, we make those resources or metadata available in our metadata knowledge graph. Here you can see just examples of those landing pages. We have 10 nodes, including the EOSQ node, with a static landing page already available. If you go to the association website, you will find all the information about these. This is just the back-end view, how we see it. 9 of them are fully enrolled. There is 1 in pending where we have to check the AAI workflows, and the other 4 node candidates are in draft stage right now. Those are mostly the onboarders. So how you as an end user will see this is primarily via the Resource Hub, which is our catalog service. Don't go to the production instance now because you won't see it today. It's all in our testing environment, so it's screenshots from the testing environment. But on the left-hand side, if you go to the Resource Hub and pick the services, you will find 7 nodes. All those 7 nodes are making their service catalogs available, and find the service catalogs over there. And on the right-hand side, if you go to the data sources, we have 2 more, so 9 altogether node candidates making their data sources available on the Resource Hub. So that would be your primary engagement point, looking for services and data sources in the EOSC Federation. Again, the final thing, probably how we support the community, is with our open source code. So there is a special section on the EOSC Node website where you can find all the code that has been newly developed for the user space and all the end user engagement workflows of the EOSC Node, with some existing code, open source, which being used to build up the EU Node. As you can see today, it's all open source, released under open source licenses, so go there and you can grab it. The documentation part, of course, there are some documentations available on GitHub, but there will be gradually more documentations are coming. Finally, I would like to show you 2 video demonstrations about 2 capabilities which are absolutely core to the whole federation, and where we made, I think, a remarkable and significant achievement, so to say. One is the core capability of AAI, authentication and authorization, and the other one is in the application domain. That's a cross-domain workflows of the file sync and share solution. So on the first one, this is actually more than 6 years of cumulative development coming from all of you, right? So this is not the achievement of the EOSC Node, it's the achievement of yours, right? It's all the achievement from the community, pointing all the way back to 2019, where the first final results of the ARC project was presented as a blueprint architecture, all the way today, where we have an operational federation working. And the great achievement is that we have 9 different AAI systems integrated, only 9 because the Italian node and the DTO node is using the same AAI, as well as the life science node and the BBMRI using the same AAI. And we have the free onboarding scenarios where only the single sign-on part has been implemented so far, but we're working on the cross-node interaction as well. So this is a huge achievement. You should not underestimate the importance of going something from a blueprint all the way to an operational infrastructure, which I would like to demonstrate with a case now. Many of these AAI workflows, if they are deployed properly, you won't see them. So it's very hard to demonstrate as such. But for that reason, we used a particular use case with Surf. So this is a use case between the Surf node and the EOSC EU node. It might go quite fast, but let's see if I can tell you what's going on. So we used Mirella. She is a Dutch researcher logging in to the EOSC EU node using the Surf IDP, so home credentials, right? Only this time she will log in once, right? She will find herself inside the EOSC EU node where she logged in. She can search in the resource catalog, as I said, for the Surf node and for the Surf services. So that's the way for a researcher to find services on other nodes. You have to go to the Resource Hub and you filter for Surf and find the Surf Research Cloud. So once she clicks that, she will be redirected over to the Surf node, okay? There is the notice that you're leaving the EOSC EU node, and she's now inside the Surf node and the Surf Research Cloud service. Notice that there are no other login page popping up, right? So this is a cross-node authentication workflow between the EOSC EU node going to the Surf node. From this point on, Mirella will stay on the Surf node, right? She doesn't need to do anything with the EOSC EU node anymore, right? We don't want the researchers to go to the new node and find all these new workflows and learn all these things there. We want her to work on her home environment inside the Research Cloud, right? What she's doing is that at this moment she's creating a Jupyter notebook. And if you noticed, it was quite quick, but there are 2 flavors of the Jupyter Notebook. One is running on the EOSC EU node, and the other Jupyter Notebook, which is she's creating now, can run on the Surf node. So basically, from the Surf node, using the well-known workflows of the Surf Research Cloud, where she lives in, she can actually launch a service inside the EOSQ node, which is a Jupyter notebook in this case, right? So this is a cross-node service orchestration workflow that works partially due to the single sign-on and the cross-node double AI capability in the backend, which you can also see. She's showing one Jupyter notebook. This one, I think, is running on the EU node, and the other Jupyter notebook is running on the Surf node. And she can, again, click on the service without any additional login. She will find herself inside the one Jupyter notebook on one side, and also the Jupyter notebook in the EOSC EU node side, right? So cross-node orchestration with the supported double AI workflows in this particular use case. Again, everything is in testing development for now. The next step would be to roll this out into production. So that was a core capability double AI. As I said, we have another interesting application domain, which is the file sync and share. So this is almost 10 years of development. You may recognize the 10 years younger and 10 kilos shorter myself on the picture. When we first demonstrated in 2016 a very handmade demo of the cross-domain interoperability. What has happened actually on the birthday of the EOSQ node, the 23rd of October, out of luck, is that now we have an IETF working group approved for standardization on this, right? And again, you should not underestimate the 10 years of hard work done by the community and done by you to achieve this, right? So if we manage to get this standardized under IETF, that would be a huge step forward for this particular application. And as you can see, this is all in multi-technology. We have OnCloud, NextCloud, CernBox, OpenCloud. And obviously for the IETF standardization, you do need multiple deployment of the same solution in operation in order to prove the actual standard, right? We have multiple nodes involved in here. Again, quite quick video. If you want the shorter version, come to the booth. There will be 3 parts of this video. The first part would be a federated sharing between CernBox and OnCloud on the EOSQ node. And the other 2 will be an example of an invitation workflow, which we all work on. One would be a nice solution using emails and the Where Are You From service. That is not in the EOSQ node yet. It's contributed by Sunet. Sunet is not yet a node candidate, but we very welcome Sunet to become a new node candidate in the second wave, because they are bringing in an important development piece which would be useful. The last part of the demo would be thing that we can do today, which is invitation based on a shared link. Not that elegant as the email one, but you will see that working. So the first part, federated sharing. For this, we have I think Giovanni from CERN logging into his CERN box, creating a federated share folder and to his own user. And when he goes over to the EOSQ node, so that was CERNBox, and this is now OnCloud running on the EOSQ node, he will find the shared folder with all the files in there that he stores physically in CERNBox, but actually can browse and access from the OnCloud solution on the EOSQ node, right? So there's no need for data movement. This is the nice solution invitation, user invitation based on email. So you see that there is an email going out from Surf to Sunet. Then there is a nice Where Are You From page where you have to see where your user is sitting on, and then you get invited. We cannot do it right now. What we can do now is this one. This is between the EU node and Surf. So this is cross-technology. Okay, so this is OnCloud and NextCloud. And what we can do here is to create an invitation link, which you need to pass over to the other side, some kind of secure channel, maybe a secure chat in this case. So this has not been solved. It's not that elegant as the email, but as long as you have this token, you can insert, you can accept the token on the other side, and the federated sharing is done, or the invitation to the federated user is done. So this one, again, is working today, all in test environment, as I said, everything which I've showed you on the onboarding and the federation and the enrollment are testing. So of course, the next step is just to go into production. Of course, technically speaking, we don't see too much of a barrier anymore, as you've seen all these results. A lot of conversation is needed on the legal and administrative and other aspects of that. Anyways, find us outside at the booth if you're interested in more. Thank you.
you. Okay, very small next step. But first, we are going to hear about use cases, federation in action. All right? So I'm going to call the 3 presenters of use cases, which was selected because of the multi-node dimension of that project. So Giovanni, actually, you can go directly here, and the other 2, you can sit here. So Giovanni Guerrieri, you're a researcher at TERN, and you're going to present us Rihanna.
Afternoon, everyone.
So you'll get your slide. Yeah.
All right, so there are 2 main items that I would like to point out in this slide, except for the title. The first one are the entities that are at the top of the slide. There are currently 6 different groups of people that have participated to this use case. And this use case is all about collaboration. So we have CERN, we have CSC in Finland, we have the EU node, we have ICSC in Italy, we have Poland with NSC, and we have SURF in the Netherlands. The second item I would like to point out is the fair word in front of the subtitle, which is going to be more or less leading our way through the whole presentation and demo. We're going to have the first half of the FAIR principles, justifying what is our challenge and why we need a federation. And the second part of the FAIR principles will lead us to the how we actually have implemented our solution. So let us start with the Large Hadron Collider, for short LHC. It is at the moment the biggest and most powerful accelerator, particle accelerator that we have. We take protons, we pack them into bunches, we accelerate them, we smash them into each other. The protons break, whatever is inside gets rearranged, we produce new particles, and we study those new particles. And all these, let's say, interactions happen at the center of some detectors that are big machines that allow us to take pictures of whatever happens. Now, how often do we take a picture? We take more or less 40 million pictures per second, which is a pretty high income rate, if you ask me. And each picture looks like this. It's a pretty complex mix of new particles being produced, thousands of new particles being produced, new tracks, energy deposition, and whatnot. And what we do with these events is we try and understand the underlying physics that is, let's say, driving the whole production. And this is what we typically try to figure out. We have, for instance, the production of a Higgs boson, which is a pretty famous particle discovered a bit more than 10 years ago. And what we do is we imagine, thanks to our, let's say, theoretical frameworks, the Standard Model, for instance, we imagine how it should work in principle, in theory. So we have a Higgs boson being produced after the collision. This is the diagram on the right-hand side. It decays into 2 different particles, and these particles decay again into what we call the stable products of the collision, which we call final states, right? The Higgs boson production is a fairly rare event. It happens once every few billion events, let's say. An event is a collision, we call a collision an event. And this is what we expect from the theoretical framework, right? On the other side, what the detector gives us is this. So there are no labels, there are no colors, no interactions whatsoever. We only know that there are 4 particles being produced at the end, and we don't know what happens before or inside of the process. So what we need to do is to simulate the data to have a way to compare what we expect from the theoretical framework and our observation. And experiments at CERN and at the LHC do exactly this. They simulate up to 200 billion events per year, every year, which is a sizable amount of data that is achieved within LHC through a federation, again, which is called the Worldwide LHC Computing Grid. And this federation allows each researcher to have the access to a huge amount of compute and storage in order to produce the simulations to be compared, let's say, with the observations. And then we try to figure out whether there are differences in our way of intending physics and whatever actually happens, right? Then researchers use the data, they publish their things, and then after a few years, we release both the collision data and the simulation as open data for the benefit of the external communities of experts that we have, for instance, and are interested in analyzing the data. And what we do, why do we open this data, is for two main reasons. The first one, of course, that the data is unique. There is only one place in which we can produce such data, so it's useful to have it open because it's the only way, it's the only way that people can get access to it and also find it, let's say. And the second reason is the scale. We produce these 200 billion events using means that are typically hard to reproduce by individual researchers or institutions or even countries, so we need to have a federation. The WLCG consists of more than 170 data centers that are collaborating with a trust network and cooperation. So this is the second reason, let's say. And let's say all of this in order to address two main challenges that both our researchers in our community and the external ones have, which are pretty similar to what Monsieur Lemaitre mentioned before when talking about AI. So it's data locality. How do I run my analysis on something that is too big to be moved anywhere and I don't have it on my premises, or that I don't have direct access to, for instance? And the second question is about computing capacity, meaning I have the compute to do this, but it's elsewhere, and I need to ship my stuff over there in order to make the analysis happen. And this is what we focus on with the use case with Rihanna. So let me introduce you to the platform that we use, Rihanna. It has three main characteristics. It's declarative, meaning that you can write whatever you want to have in your workflow and in the order you would like, using one of the common workflow languages systems that are supported, for instance, and these are in the bottom left part. It's scalable. You can plug compute backend, Kubernetes, batch system, whatever you have, and it works as far as it's supported by Rihanna, and if it's not supported, we can include it. And then finally, the in Rihanna is because it's reusable, it's containerized. You can ship containers, you can preserve your analysis, you can rerun it as much as you want. And in order to make this happen, we actually changed the code base of Rihanna. We added 4,000 lines of new code to enable the federated distribution of workflows. It's not a negligible amount of work. And you're going to see in the video that this, on the user side, this results in a single line that you can explicitly say to, which means where to send what workflow, for instance. So the other item is the software. So we have a significant, let's say, portion of the analysis run on the CMS software. CMS is one of the CERN experiments. You may or may not see up there that it has 250,000 commits, it's highly maintained, and it is very well preserved. It has more than 1,000 different releases. We're going to pick one from 10 years ago, and we're going to rediscover the Higgs boson. And this is what happens. So we have 6 actors that are part of this. We're only going to use 3 of these for the purpose of the demo, but everything works regardless of the order or the actors involved, right? If the video starts, we have, for instance, then Italy, we have CERN, we have the UNODE, we have SURF in the Netherlands, we have Finland, Poland will appear later. As of now, we're going to focus on the 3 blue ones, all right? And then we're going to have Poland appearing as one of the users that submit the job. And you can see there the attribute I was mentioning before, that single line that allows you to distribute your workflows. So let's say that the user connects and it has their Rihanna dashboards there, and they can create a workflow, they can upload all the necessary script that they have in order to make the workflow happen, and they can start the workflow. Then immediately, whenever the workflow is started, the node that acts as an orchestrator, in this case CERN, will manage the jobs and will ship, let's say, all the analysis to both SURF and CSC. And there you can see the analysis going on. You can see a loop over the various events that we have. The events are characterized by a run number, right? And the run number is the number that changes in the loop. Then we go through the events. We analyze both data and simulation. Eventually, our loops finish, we achieve all the selection criteria that we want in order to make sure that we have candidates Higgs bosons, let's say. And then whenever the loops are over, the products of these analyses are shipped back to CERN and assembled together. We can already preliminarily, let's say, navigate the histograms that we produce, but if we wait a bit more, the RIANA platform will assemble a final plot that will allow us to make sure that we have, let's say, a plot regarding the Higgs boson. So in this case, what is useful to know is the shape of the distribution that is produced with partial data, for instance now, and on the left, the original, let's say, the original discovery. So shape-wise, and also the position of the red peak is compatible, which means that also our open data retains some physics, some significant physics that allow, say, as other communities to actually produce reasonable results. Which brings me, this whole thing brings me to, let's say, 3 main items that we want to somehow try and transmit to everyone else. The first one is scientific item. We have enabled RIANA, but in general we have enabled, or we are trying to enable, our federation to run executed, or to run execute workflows, let's say, a la WLCG, so in a distributed, federated way. We try to enable near data computing, as well as we try to expose the possibility of running workflows, even if we don't have necessarily direct access to the data. And then the second item is say, societal impact. We try our best in order to limit the duplication of infrastructures, but rather fostering the idea of working together towards the same goal. Being a federation means contributing to the same, let's say, objective. And finally, this is completely agnostic, let's say. This implementation is independent of the physics that you are running. It doesn't matter whether it's high energy physics or any other science. It works as long as you have your analysis written in a friendly way, let's say, for it to work. And with this, I'd like to thank you again for your attention, and that's it.
Thank you, and well done. By the way, I was looking at Slido. I see there were quite a few questions for Peter as well, and I believe there's also a booth for the EU node, right? So if you have those questions, especially regarding license, the frequency of visit by users, and so on, so all those questions can be asked at the booth or tonight at the dinner. All right? Good. We are going to move to the second case study, use case, by Björn Gröning, who is going to present us Galaxy. Björn, you're with Galaxy Europe and University of Freiburg in Germany. Please respect the 10 minutes.
Yeah.
Sorry, it falls on you.
I'm very famous for that, yeah. Yeah, thanks for having me. I mean, after CERN in Brussels, I guess I can retire now. So what I will show you now is actually a work of many, many people, and you will see that later in the video. I just want to make one point, and for me, this is all about sharing here. And what you will see is how we can share things across border, across communities. For me, science is sharing, FAIR is about sharing. And what you will see now in our small video is actually 4 different communities that solve very similar problems for themselves, but they share tools, they share one single workflow, they share an infrastructure, and they do that on the EOSC federated infrastructure. So keep in mind that this is one coherent framework where we can now bring different communities together. They can learn from each other, they can share stuff between each other in one coherent framework. And for me, this is driving then science forward. So actually, there are 11 EOSC nodes that have contributed to the following video. I will try to comment the video. Please bear with me if I don't know, don't call everyone out, because it's so many people that have actually contributed in so many different EOSC notes, but you will hopefully see it. There's a link if you want to watch it in slow motion, or visit us at the Life Science booth, the NFDI booth, the Data Terra booth, and so on. Okay, so let's see if the video starts. So this video is pretty much about climate science. We have earth science here as a demonstrator. We have life science, so these are at a microscope, and we have astronomy. So we have actually different instruments that are coming together. And they have one single problem. They want to identify objects. They want to count objects. They want to classify objects. And as I said, there are 11 EOSC nodes involved and many, many different partners. You see here in this slide how these different images look like. So there's an image from a forest, from top down, from a satellite. You have a telescope, you have a microscope. You have an earth science, you have some small robots driving in the ocean. So it's completely different instruments and how they work. So here's the first thing that we do. That's using the WAI to log in. Actually, I use here my YubiKey to log in with the two-factor authentication. And then I'm pushed back to the European Galaxy instance. The European Galaxy instance is just one of many Galaxy instances. But then I'm logged in. And now the question is, how do you get data? And in Galaxy, we provide you with more than 50 data repositories. And this goes from different EUDAT repositories, Copernicus, the 1000 Genome Project, Omero, and so on. So you can all plug that in. If we don't provide you the repository that you need, you can always add your own repository. We call that bring your own data. So you can now connect, for example, your own Zenodo account. Yeah? So your private Zenodo account, maybe your Invenio RDM account of your university, you just connect that with your Galaxy account, and all of a sudden you can now browse it and you can now import the data into Galaxy and then run your workflow. So now all these 4 different communities have these 4 different data repositories. They import the data in Galaxy, and now the question is, how do you analyze that? And yes, you can run Jupyter Notebooks, you can RStudio in Galaxy, all that is covered, so all these VRE stuff you can run. But more importantly, you can also now run workflows. And here we have also worked together with the Elixir Workflow Hub. So you can actually search now workflows from public repositories. These workflows are all versioned, you can import them. And now you have this very specific Voronoi segmentation workflow in Galaxy. This is how it looks like. It's all graphical. You don't need to know what CPUs are, what memory is. You don't need to code. You can just run this. This is how a workflow run form looks like. And now the workflow is proceeding. So you see that these boxes are turning from gray to yellow. Yellow means it's running. Green means it's finished. Red would mean it's failed. It has failed. Obviously, you will not see that in my presentation. But this is now how it proceeds, right? So the workflow is now running. And interestingly, what we will now do is in the background, and again, the user doesn't see that, is that we are scheduling actually the workflows across Europe. So we have a lot of different partners here from EOSC nodes from Poland, SURF, Germany, Slovakia, Italy, Belgium, and so on, that have actually contributed compute endpoints where we can schedule these jobs now. Again, this is a job scheduling. That's not workflow scheduling. Galaxy is distributing these jobs. And once this workflow is finished, this entire workflow with all these different steps, you can actually examine that. We give you a carbon footprint estimation of how much CO2 has your workflow produced, so be responsible. This is how the input images looked like. And now we go then to the results. So this has now produced, you see here 4 different history for the 4 different communities. And these are the 4 different results that you are now seeing. And again, everything was running in one infrastructure, in one coherent framework. It's just one workflow that works for all these different communities. And you see here that you have now this classification of images that is counting trees, cells, objects underwater, and galaxies actually in the star and at the sky. And last but not least, if you have these results, you can actually export them, of course. So you remember that we connected our Zenodo account to our Galaxy instances? You can now export your entire history to Zenodo in a fair digital object. That's the implementation of a row crate. So huge shout out to row crate. And this is now exported back to Zenodo. You get your document identifier. Galaxy keeps track of your document identifier. And we are more or less done. So just as a wrap-up, we have these different communities. Everything is documented. You have training material for that. There's a Galaxy training network with more than 400 trainings. So just check out if you ever wanted to do astrophysics, there's a training. And you can now log in with EOSC AI. You can do the astrophysics training and you count Galaxy in the sky. Yeah, that was the video. And I guess I need to click yes. So, oh, cool, 2 minutes, good. Yeah, so what you have seen is that we can now have different communities, all people learning together in one coherent framework. We also schedule everything in containers across Europe to these different endpoints. And what Galaxy is it's more or less a very simple middleware. Yeah, so we abstract away the compute infrastructure, so users don't need to care about compute. Users have a lot of different tools that they can choose from, but they also don't care in which programming language they have written or whatever. It's all abstracted away, and we offer a lot of different data sets, pre-computed machine learning models. You can run AI LLMs in Galaxy against your PDFs, against your results. But again, everyone can do that. There's no programming knowledge needed, anything like that. I was asked, or we have been asked to also say, hey, how was this created? Where we are going? And this is kind of the timeline that I would like to share you. And you see here probably that we started with 700 users. Back then it was a very tiny Galaxy instance in our University of Freiburg. And then with the help of Denby, Elixir, and substantial EOSC initiatives like EOSC Live, where we created actually Workflow Hub, where we worked on row crates and so on, we actually could scale up. And what you are seeing here, this line, is the line of users. So you see here active users using the service. And we are now at a scale where we have 140,000 users, and you see that this correlates pretty much with the EOSC initiatives that Galaxy has been used, or where EOSC initiative used Galaxy. Right? And this is then scaling up users. So I think what will happen next, and let's see, ask me in 2 or 3 years, I think what we will see, we'll have more national servers. So there is more than just a European Galaxy server. There's a French Galaxy server, there's a Belgian Galaxy server, a Czech Galaxy server, and so on, an Italian one. There will be very soon a Swiss Galaxy server, all running on national resources. They all will hopefully become an EOSC node. We can interconnect all these nodes to share resources, to share workflows. 7 seconds. And maybe we can hit in a few years, maybe in 2 years, the 300,000 users with the help of EOSC and the community. And with that, done.
Well done. Perfect. On timing. Look at that. No, take it easy. It's okay. That's perfect. The good news for you is that we won't have time to take questions. So you can relax. And the 3 gentlemen have a booth out there. So that's where you can ask all the questions you have. But before we go to that, we have a third and last presentation of use case by Andreas Türk. You're going to tell us all about MCVAL, right? And you are from the European Research Infrastructure Consortium for biobanking and biomolecular resources. Andreas?
Yes, you got it right.
Go ahead.
Yeah, so this presentation was originally meant to be given by myself and Peter. Unfortunately, he could not travel today, but he might join for the Q&A online later. Okay, so this is about the MCVAL use case. MCVAL stands for multi-centric validation of AI models for prostate cancer screening. And as you can see from this slide here, we have quite a few EOSC nodes collaborating with us on this, providing data and compute resources. And in the bottom row, we also have different institutions representing research communities and data holders, and also clinicians. Okay. Yeah. So to give you a bit of a background, so how does screening work? So you can imagine here you have a digital pathologist on the left side. He's looking at whole slide images, which are cross-sections of biological specimen, for instance, from biopsies, right? And so the work of this digital pathologist is this person selects a region of interest, zooms into the region, analyzes the selected region, and then repeats this whole process. And so how can AI support the digital pathologist? Well, AI-assisted whole slide image screening actually does image segmentation automatically, performs individual segment analysis on all the segments, and can guide the pathologist by highlighting segments of interest. So the digital pathologist does not exit this picture here, so he's still very much deciding what the diagnosis should be, so the AI is not taking over. So I think this is an important point. So what's the scientific challenge of bringing these AI models to a hospital? So if I want to deploy such an AI model in hospital A, I have to realize that this model was most likely not trained on data from this institution. And we know that AI models do not generalize well to data acquired from new sources, and therefore this AI model has to be validated and potentially adapted before we can deploy this in the hospital. So this is the vision and the challenge of the MCVal use case, because MCVal tries to provide a service for the multicentric validation of AI models for prostate cancer screening on sensitive health data in compliant frameworks. And compliant frameworks here means that the data has to be safe, right? So these are sensitive health data, and it would not be acceptable that these data leaks in one way or another. So there are a couple of challenges which come with this vision. So the technical challenges are, well, the AI model and the validation data must be transferred to a secure computing environment via a secure channel. One technical challenge which is even bigger is really that AI models for their development often requires a very tailor-made computing environment which is not available in secure computing infrastructures, which very often provide bare bones functionality. There are also legal and ethical challenges because it's important to develop a legal framework for transferring data and for processing data, sensitive health data across multiple institutions and possibly across different countries. And it's also important to develop a framework for ethical use of sensitive data, again, across multiple health institutions and potentially across multiple countries. So this graphic here is showing, well, who took part in this MCVal use case, their roles, and it's also going to explain to you how, what you are going to see in the next video. So on the left side of this graphic, you can see we have multiple institutions. So the first institution at the top, Masaryk Memorial Cancer Institute, is representing the clinician, so the digital pathologist. The institutions at the bottom, they represent the AI researcher. And what happens first is that the AI researcher goes to the BBMRI-ERIC directory to discover data sets which are useful for the AI validation. In the MCVal use case, the data comes from the Medical University Graz. So once the data have been found, the researcher then uses the negotiator in order to negotiate data access with the data holders. And once this comes to a conclusion, hopefully a positive one, then they can set up a data transfer agreement. And finally, the data is transferred into a secure computing environment, which in the case of MCVAL is provided by ICSC, the Italian node, and INFN. So in this use case, we have quite a few people which are involved. So you can see we have 36 experts across these different roles. And for the first initial implementation, we used biopsies which amounted to around 11,000 slides. Yeah, and so this is the MCVAL demo, which actually has sound. So let's hope that this works. I push the button and hope for the best. Aha, okay, so the sound is not working, good. So then what I have to explain to you what happens here. So we have the researcher going to the directory and selecting data of interest. And here the researcher goes to the negotiator, logs in with the account, and this is again using the AAI, AAI login from the EU nodes. And here we see that the negotiation actually takes place. And here we see the different types of AAI login that are possible. It's all a bit fast. It's also multi-factor authentication, as you can see here. And yeah, and so then finally the data arrives at ICSC, INFN, and here you can see that the researchers, the AI researchers and the clinician are actually both working together on validating the AI model. So the researchers are in the image in the middle, and the digital pathologist is in the image at the very bottom. And Peter, who could not join us today, is in the picture on top. So they are going through the reports now. And you can see this is a whole slide image which has been marked by the AI to guide the digital pathologists to regions of interest. So the yellow regions are the ones that the pathologist should look at. And the pathologist can apply different types of highlighting to these regions or switch them off. And so now the pathologist actually is coming up with a diagnosis for this particular section. And since there's no sound and no further movement, I think that's it. Good. So developments and achievements. We had to do quite a lot of stuff to get this working. So first of all, we had to get ethics votes from MMCI, approval to use the AI model, but also from Medical University Graz, approval to use their data. We also had to set up a fairly involved contractual framework, so data transfer agreements with Medical University Graz, data processing agreements with ICSC, and interconnecting infrastructure, which is the integration with the MyAccessID into life science AI. In terms of compute infrastructure, there was a lot of work happening at INFN and ICSC, so big thanks to everyone involved who put in the extra hours and made this work. This is actually not really totally up to date because the provision of resources is complete, the permission management is also complete, Kubernetes is deployed, and the deployment of the AI pipelines has also been finished. So what we learned from all of this is we get a blueprint for handling sensitive health data in the sensitive health data subgroup. And here on this slide, there are two main messages, really. So what we want to show here is the societal and economic impact. As you can see from the first point, prostate cancer in Austria, for instance, you have 141 cases per 1,000 people in the population. And so you can see that this is clearly a very important task to approach. And if you can set up AI to work on these cases, then you can speed up the turnaround. And you can also obtain more reliable diagnosis. So this is, from a societal point of view, very important, obviously. So how do MCVAL and the EOSC Federation benefit from each other? So the contributions of the EOSC Federation to MCVAL are the EU-wide network of AI and medical experts, EU-wide clinical health data resources and computing infrastructures for AI model validation, and the ability to authenticate using EID. So the contributions of MCVAL to the EOSC Federation are that it becomes more simple to access sensitive health data for AI researchers and clinicians. There's also, we are in the process of setting up a legal framework for this particular use case for exchanging sensitive health data across health organizations. And also the collaboration with INFN and ICSC is leading to a blueprint for compliant compute infrastructures for processing of sensitive health data. And yeah, so scaling up the MCVAL use case, so I'm really going to go through this very quickly. So we have the EOSC sensitive health data subgroup where we have multiple EOSC nodes participating. We have CERT, Slovakia, and Poland, and they have been providing us with data and are going to provide us with compute resources. Yeah, and so thank you very much for your attention, and thank you for all the highly committed contributors that we had in this use case and the SHD subgroup. And so these are the credits of, would be the credits of a movie, right? But yeah.
Very good. Thank you. I'm going to call our next speaker, and you understand that something is prepared. Under preparation. We're getting very close to the peak of today. And to get us there, it is my pleasure to welcome Michael Arentoft, the Head of Unit of Open Science and Research Infrastructures at DG Research, European Commission. Michael, over to you.
Thank you very much, Marilyn. I was not sure if the table or the stand was for me, but I will take the stand. And also I hope, because I see there are many good questions on Slido, that these will be picked up tomorrow or the day after tomorrow. But if you would allow me, I would like to spend just 1 minute to go back 1 year in time. It was mentioned already when we launched, of course, the EOSC EU node at the symposium in Berlin. You may say at the time, 1 year ago, we planted the first seed in the ground, and I recall this was also on many of the slides 1 year ago in Berlin. We planted the first seed for what we envision as the EOSC Federation, namely a thriving forest of interconnected nodes. You can also say we began with a fertile land, and now we are cultivating that with diverse and flourishing trees in an ecosystem. We started this cultivation in parallel to the preparation and the launch of the EOSC EU node last year, when we initiated a call for interest to contribute to this collective effort. And in March this year, as we have also seen previously today, many of the 121 organizations that responded to the call came together in the nodes that we now have seen in the first wave of building up the federation. So you might say that these 13 nodes have planted their own very strong seeds next to the EOSC EU node. So today we are starting to witness a very remarkable progress made by all of you, all the involved organizations. You can say that we are starting to see the first saplings of nodes that are taking root. These are national nodes, they're thematic nodes, they're e-infrastructure nodes that are being developed. And in particular, through the session that we have just seen, we have seen use cases, we have seen a functional ecosystem that is emerging. You could also say that this remarkable progress over the last 10, 11 months is starting to demonstrate the real potential, the real added value of EOSC to scale up the sharing, to scale up the reuse of data, of tools and services at the European level. Now, to realize this potential, we have, as we have also seen during the day, a number of challenges. Let me mention just 3 of them. I think the first one I would like to mention is the need for the glue to put together the EOSC nodes, to connect their roots, if you like. We need to keep increasing the federating capabilities. We need to keep increasing the cross-node service integration. The second thing I would like to mention is, and it was also mentioned earlier by several speakers, we need to ensure this very strong uptake by the researchers, by the research communities. We need to make sure that all the developments remain very responsive to these actual user needs. And thirdly, we need to develop ways that will allow any high quality, any community endorsed service or data set to easily find its way into EOSC and add to the added value of the federation. Now, of course, we should not underestimate the complexity and the scale of these challenges. We fortunately have a very good plan to tackle these challenges, starting, of course, with the build-up phase that, and I insist, will continue to be community-driven. It needs to continue to reflect the diversity, but very importantly, the richness of the research community that the Federation is serving, and to meet, indeed, the needs of these researchers and the research communities. The reason I am intervening just before the ceremony of the nodes that have joined the first wave is that we, as a tripartite governance, we are opening, and it was also mentioned already, the call for further nodes to enroll. And this opportunity for further enrollment of nodes, we intend to keep open until February next year. So it will allow further countries, it would allow further organizations to prepare for planting their own very strong seeds during the spring and during the early summer of 2026. To provide more detailed information on the expectations for this second call, of course, we're building on the very rich experience of the nodes that have joined the Federation this year. We want to help, we want to guide the evolution of this common forest that we are building. We want to cultivate a forest which is very rich in species and that benefits all researchers. So you will see that the second call will identify, of course, again, national thematic e-infrastructure types of nodes. So today we're inviting countries, we're inviting research organizations to reflect on their readiness for this call, and we will share much more information about any practical aspects at tomorrow's plenary session, which starts at 10 o'clock. I also want to remind that not everyone may be ready for planting a next seed in the Federation at this point in time. So you will also hear tomorrow that one of the projects that we are funding under Horizon Europe, namely the EOSC Gravity project, will open 2 calls for grants. One is to support organizations that are interested to make available their resources in the Federation through one of the EOSC nodes. Of course, so this is the onboarding of resources onto one of the nodes. And also EOSC Gravity will open a second call to support organizations that want to increase their readiness to become an EOSC node, so towards later calls for enrollment of nodes. So allow me, before I wrap up, to reflect beyond the second call for further notes to enroll. As I already reminded, the EOSC Federation needs to continue to be driven by the research community and also count on its own voluntary activity for its development. Of course, we will also help from our side and from the national side with several different types of grants. Of course, coming from our side, from Horizon Europe, addressing some of the challenges that I highlighted, and in parallel also looking into what happens post-27. So we also had a discussion on that, what will be the future financing, the future governance, and in general the future sustainability of the EOSC Federation. So as this time for decision also on what kind of support would be needed for EOSC in the next Horizon Europe program, now it's time for all of us to showcase the value of the Federation so far. It means to advocate to your communities, to advocate to your funders, to advocate to your public authorities, national authorities, for a strong EOSC, for a very sustainable EOSC, also post-27. I'm sure that together we can make this happen. We're doing everything we can from the side of the European Commission. So now all I want to end up with is that I'm looking forward to the ceremony, looking back and celebrating the last year of achievements, but also very much looking into the next waves of attaching even further notes to the EOSC Federation. Thank you very much.
Thank you, Michael. So now is the time for the celebration, for the EOSC Federation ceremony, and to tell us why we have a magician table on stage. I will actually hand over to Ute Güntenheimer, the Secretary General of the EOSC Association. Ute, over to you. You take us through.
So, thank you very much, dear colleagues. Good afternoon. It's my pleasure and my honor now to guide you through this MOU, Memorandum of Understanding ceremony. And it's our joint opportunity to thank all the organizations who have been behind this build-up group and EOSC notes and have supported it and make it happen that we are here celebrating here today. So what I expect from you is here lots of applause in the next minutes in order really to celebrate all this in-kind effort that has been contributed over the last year. So if we go to the slides, what are we actually signing here today? It's the shared path to operations, to the next phase. It's the Memorandum of Understanding, and it is a collaboration or a signature process between the EOSC Association. These are the next steps, maybe you just bring it up, between the EOSC Association and the EOSC notes. Is legally not binding. And this work has been jointly done in the EOSC Federation Build-Up Group and has been led and coordinated by Peter McCallum from Elixir. So someone has to please click the next clicks open. What's the scope? It sets out the mutual understanding of roles and principles for interim collaboration among the participants with the sole purpose of testing and preparing practical approaches for future participation in the EOSC Federation. And during this phase, the participants aim to establish approaches and frameworks for future service integration, interoperability, and quality assurance. And these are preparatory steps and are intended to lay the foundation for an operational model for the future binding agreements. Now, what are we doing here on stage today? Actually, the only person who's going to sign live here on stage will be the EOSC Association President, Klaus Tochtermann. Klaus. You need to take this microphone, please. So, Klaus, this is it. You're going to sign it. Have you read it?
Here's the pen.
Very good. So, and why is this such an important milestone today?
Because it somehow formalizes our joint commitment to the European Open Science Cloud. So this is the first common understanding which is or will be signed by all participants of the EOSC Federation, and it is just an explicit expression of how committed we are towards the EOSC.
Very good. But before we do that, I will place it here. You have your pen, you move to the left from my side, and now it's time to celebrate the notes. So we start in alphabetical order. And we start with BBMRI and Andreas Türk standing in for Peter Hollop today, the Deputy Coordinator. The BBMRI area consists of 22 member states and 3 observing countries, plus the WHO, and has more than 500 biobanks. You have to move here next to Klaus, please. And a big hand for everyone here. Then, the next one is the EOSC Node CERN with José Benito González López. And we do have in this thematic node next to CERN contributions from Inspire, HEP, the Durham University, and Escape Partners. Thanks very much. The next thematic node I've asked on stage is Datadera with Alessandro Rizzo, and we have CNRS being the leading organization together with 12 other partners from France. Welcome on stage. I think I have to go over here then. Then the next one is the digital twin of the ocean with Dick Scarp, representing then together with the partners from CNR 26 organization contributing to this thematic node. So then we have the EOSC node EUDAT. It's the e-infrastructure node, and we have Jos van Wezel as the deputy coordinator joining us here on stage, EUDAT, with more than 20 organizations from 17 countries across Europe. And we need to line up behind it, yes. We have already celebrated the first birthday today. Peter Szegedi from the EOSC EU node, come on stage and join us here. The national node from Finland is being coordinated by Jessica Palan van Essen, and she is representing the CSC IT Center for Science. Please. Women power. So, Germany is coordinated by Jörg Surefette, and there we have the NFDI, the National Research Data Infrastructure Association, being the coordinator. We continue with Italy and Matteo Sanaroli, and he is in ICSC leading on the Italian effort with more than 50 Italian organizations contributing to it. Matteo. So, then we have the EOSC node Life Sciences Connect. The thematic node brings together and is coordinated by Peter McCallum, the Elixir, EMBL, Eurobioimaging Eric, and Instruct Eric. Welcome on stage. So, the photon and neutron community is organized in the EOSC node PANOSC, led by Andy Götz, and the coordinating organization is the ESRF, the European Synchrotron and Radiation Facility in Grenoble, and its 11 organizations and the Photon and Neutron Network. Continuing with women power, we have here EOSC node Poland, Aneta Pacyk-Aiba, from the National Science Center, and they bring together the Syfonet, the Gdansk University of Technology, ICM University of Warsaw, and the Institute of Oceanography. So. Then the last national node is the EOSC node Slovakia with David Cymbalek from the Slovak Center of Scientific and Technical Information, CVTI-SR. So, and the last of our nodes, Laurens Sissing from SURF, the IT cooperative of Dutch education and research institutions. Come on stage. So, these are 14 EOSC nodes, but without the leadership of the special envoy of the EOSC Association, Bob Jones, this would have never happened. Welcome him on stage. So we have to make sure that you're all, maybe you can move a bit together because we have to stand, no, it's move so that you put, guys, you come on this side. And Klaus, the floor is yours. So before you sign, we need to check that the letters are all right. No, don't, you sit down and wait. Okay. Please hold up the sign and show what we are, the EOSC Federation. Let's see whether we get this straight. Oh my God, celebration and signature. Woo! And standing ovations are appropriate. Okay. Thank you so much. Well done. And the party will continue here. We start at 7:45 with some aperitifs in front of the door, and then we have a seated dinner here in this room at 8 o'clock. Join us there. Don't go home. And it will be then the continuation of this Federation party. Thank you very much.